12, is you have to do a substitution. Anytime you see a 2x, that means it's a double angle. So we need to do a substitution.
Wait, 2x.
It does. It means double angle. If you multiply by 2, you are doubling it. So for cosine 2x, do you all see, if you look at your pink paper, you have 3 choices. So what you want to do is look at the rest of your equation. Notice that the rest of your equation only has sine. So the best option for you would be your third equation under double angle. So what I'm going to do is in place of cosine 2x, I'm going to put 1 minus 2 sine squared x. And that equals negative sine squared x.
The A and I didn't just mean variable.
That's a variable. And I think on your paper it says theta. It's a variable. So I think at this point it might be a good idea to do a u substitution. So I'm going to rewrite this as 1 minus 2 u squared equals negative u squared. And I want you to solve that for u. How are we going to solve that for u?
So if it's ever the same thing, you can just put in a random variable to look better or easier to understand.
Sure. And most professors use the letter U. Sorry, I'm trying to find my Okay, so how are we going to solve this for you? What's our first step? Okay, let's go ahead and add 2u squared to both sides. So we'll have 1 equals 1u squared, or u squared. And then we're going to do what? And when you take the square root of a number, you have to remember that you get 2 answers. It's plus and minus 1 equals u. So now we're ready to put, what do u represent again?
Sine.
So we know that the sine of x equals 1 and the sine of x equals negative 1. So look at your unit circle and tell me, where is sine positive 1? Where is sine negative 1? So sine is positive 1 at pi over 2. Sine is negative 1 at 3 pi over 2. And that is your 2 solutions right there.
And when you say whenever you square root a number, it always gives you 2 answers?
Yes. So the square root of 16 is plus and minus 4. The square root of 100 is plus and minus 10. Yes.
That's it, you start there.
We're done. We found our solutions. All right, let's copy down our next example. Go ahead and copy this down. So do you see a double angle? Is there a x being multiplied by 2? Yep, right here. So we have to do a substitution. So look at your pink sheet. Look at the back. What substitution do you think we're going to do this time? The rest of our equation only has cosine. So would you use the first one, the second one, or the third one on the back of your pink sheet? The second one. So I'm going to substitute. So I have cosine squared x minus. And now inside of the parentheses, this is what I'm substituting in. 2 cosine squared x minus 1.
Why did we choose that one?
Because you have to look at the rest of the equation. What trig ratio are we using every other place? Cosine. If you look at the last example, we had a sine, so we use that substitution. But for this one, we have cosine, so we're going to use this one. So now let's distribute. So we have cosine squared x minus 2 cosine squared x. And what's the negative times the negative 1? What do you think we're going to put next? Plus 1. Because we have to distribute that. So I think this might be a good time to do a little substitution here. So we're going to say u is cosine. So we have u squared minus 2u squared plus 1 equals 1/2. Go ahead and try to solve that for u. So when you subtract this, what is 1 minus 2?
-1.
So we got negative 1 u squared plus 1 equals 1/2. And then we're subtracting 1 from both sides. So negative u squared equals, and we got 1/2 minus 1. It's negative 1/2. So I got a lot of people a little confused. We got 1 over 2 minus 2 over 2, which gave me negative 1 over 2. So this is really a 2 over 2. So that's how I got that. Yes, Lyric. So going back here, this was a minus sign in front. We have to distribute the negative. So I have to multiply the negative by the 2 and then a negative by a negative, which makes it positive. All right, so now we have to divide both sides by negative 1, which gives you u squared is positive 1/2. Now we're ready to take our square root. So u equals plus and minus the square root of 1 over the square root of 2. When you take, let me go back up. When you take the square root of a fraction, you are square rooting the top and bottom separately. So we get u equals plus and minus 1 over root 2. What do I have to do now? Well, not quite. We're not quite there yet. We have to get rid of that root 2 in the bottom. How do I get rid of the root 2 at the bottom? Multiply top and bottom by root 2. And then we have u equals plus and minus root 2 over 2. So now you're ready to tell me, where is cosine equal to a positive root 2 over 2 or a negative root 2 over 2? So there's 4 answers that I'm looking for. So looking at your unit circle in each quadrant, what would you get? So you should have pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. And that would be your answers. Okay, any questions about how we did that? So now you should be able to do numbers 1 and 2 on homework 12. So the last thing we're going to talk about is half angle identities. Does everyone see half angles on the back of the pink sheet? So we got 2 more examples and then we'll end there. I'll give you a minute to copy this down. This is a half angle. Okay, so in my honest opinion, these are the hardest identities, okay? Only because they look really ugly. Because if you look at these identities, they have a square root and they have a fraction. So it's doing a lot. So the first thing you have to tell me is, what angle on our unit circle can I take half of and get 22.5? So what angle divided by 2 that's on our unit circle, which one do you think I can divide by 2 and get 22.5? 45. That's important. So I know that theta, or whatever, is going to be 45 in my formula. Okay, the second thing that I want you to, and we need to figure out, is what quadrant would 22.5 degrees fall in? Show me with your fingers, what quadrant do you think that will fall in? Quadrant 1. And then quadrant 1 is sign positive or negative? Positive. So that's really, really important, because this is the identity. I'm zooming in really closely. This is the identity that you have on your pink sheet. And do you notice how we have a plus and a minus in front? That is determined by the quadrant. So this depends on the quadrant we're in. Okay, and we established that we're in quadrant 1. So that means that it's positive. So we're ready to go. So we're going to figure out the sign of 45 divided by 2, because 45 divided by 2 is the same as 22.5. That equals a positive, take the square root, make your fraction. It says 1 minus the cosine of the angle. And the angle we're using, again, is 45. And that's all divided by 2. Okay, so now we need to go to our unit circle and figure out what that number is. What is the cosine of 45 degrees? All right, so I have 1 minus root 2 over 2, and that's all over 2. So I think what I want to do at this point is I'm going to approach it a little differently than I did 5th period. Is I'm going to break this apart. I'm going to write this separate from this, okay? And put the division symbol in between instead of a fraction. So what we have is a plus sign. And then I'm going to put my numerator in green. So it'd be 1 minus root 2 over 2. And that's divided by my denominator, which is a 2. Okay. So now that we have it broke up, Let's look at what I have in green, which is my numerator. What do you have to have in order to subtract a fraction?
Common denominator.
Common denominator. So how can I rewrite 1 so that it has a 2 at the bottom? 2 over 2. So let's do that. And I am not skipping a step. I am showing every single step because I do not want anybody to be confused. So I'm going to rewrite this. So again, the green is my numerator. The red is my denominator. So now that we have our common denominator, we can actually bring the numerator together. So plus square root. So I have 2 minus root 2 all over 2 divided by. Now, would it confuse you if I wrote 2 as 2 over 1? Do you all agree that every number has a denominator of 1? Okay, so now we have to divide 2 fractions. How do you divide fractions? Keep, change, flip. So let's do that. So I'm going to keep the first one. Change this to multiplication and flip. So now we're almost done. And again, when you're working this on your own, you probably won't show every single step like I'm showing you. Because some of these steps you can probably do mentally, but I want to show everything because I don't want anybody to be confused. Okay, so now I'm ready to multiply straight across. So now I'm going to make one fraction. No longer will we have a numerator, and we're going to have one. Instead of 2 fractions, we're going to have 1 fraction, I meant to say. So we're going to multiply these together. Well, 1 times anything doesn't change it. So that just becomes 2 minus root 2. And that's all over 2 times 2. And what is 2 times 2? 4. Okay, so we're taking the square root of a fraction. And when you square root a fraction, are separate. Okay. So I'm going to rewrite this one more time. And this time, I'm going to put a square root on the top and a square root on the bottom. And this is really fortunate for us because remember, we can't leave a radical in our denominator. But because 4 is a perfect square, it takes care of itself. So my final answer is you're going to have 2 square roots. So you got to have a square root, and under that you have a 2 minus a root 2. And that's all over 2. Now keep in mind that we agreed that this is positive. Now at some point I did drop the plus because we all know that not having a sign means that it's positive, right? So I stopped carrying that plus sign. But if it's a minus, we do have to drag it along. But this is my final answer. That is the sine of 22.5 degrees. Any questions about how we got to our destination? I know that was a lot of fraction work. It's really just a lot of fraction work.
So in the numerator of the green, you wouldn't have been able to cancel out those 2's, right?
No, we can't cancel out anything because it's subtraction. Yeah, so we can't do anything. There is nothing we can simplify because we have subtraction, and then that other 2 is under a square root, so we're done. Yes, Osmil?
Why did we use the sign
Because it said find the sine of 22.5. So we had to use this one. Good questions, though. We got our test next Tuesday. You get your study guide tomorrow. So, yeah. All right, last question, and then we'll be finished for today. Go ahead and copy this down. Let's do one in radians. Now, radians is a little trickier. And notice how it tells you to use the half angle. That's how it is on the test. It'll say, because some of these you could do it, like I could do a sum and difference to do 7 pi over 12. But I want you to show me how you would do it with a half angle. So you have to use the identity that we're asking you to use. So for this one, we want a half angle instead of a sum difference. Okay, so this is a little tricky. I'm a little scared though. I'm gonna ask the question. Does anybody know how we'll figure out what angle we're working with on our unit circle? Because it's easy to figure out what angle is half, what angle to take in half when it's in degrees, but anybody have a clue how I'm going to approach this? Because it's 7 over 12. So what you would do is double that. So if I double this, if I take 7 over 12 times 2, then what would I get? 14 pi over 12. Which means that this is half. Okay, so this is my angle. Now, what is this reduced down to? What is 14 over 12 reduced down to? 7 pi over 6. Okay. So that's important because when we do this identity, let me zoom in. Every place where we see an A or a theta, we're going to put a 7 pi over 6. Okay, now here's the hard part. And we haven't talked about this in a while. We have to figure out what quadrant is 7 pi over 12. So I want you all to think about it.
Can we do the thing where we did pi over 2 is half?
Yeah, that's exactly what you're going to do. Yeah. So I want you all to think about it. And then in a minute, I'm going to ask you to show me with your fingers. Because this is the hard part. I mean, radians is harder than degrees because we're dealing with fractions. Okay, so now show me with your fingers where you think we are. We're in 2. We're in 2. So remember, this would be 0 over 12. What's half of 12, guys? This would be 6 over 12, and this is 12 over 12. 7 is in here. Okay, so this angle is in quadrant 2. So we're in quadrant 2. So we need to write that down because that's really important. And when we are in quadrant 2, is cosine, because we're doing a cosine, not a sine, is cosine positive or negative in quadrant 2? Negative. So when I look at my identity, and this is the identity that I'm working with now, do you see how it has plus or minus? So because we are in Q2, we're going to keep the negative. It's negative. That's how I know if I'm starting with a plus or a minus. The last example was 22.5. That's positive. So we started with a plus. But this example is 7 pi over 12. That's in quadrant 2. So this is a negative. So we're ready to go. So we're going to take, in order to find it, we're going to take the cosine of, and then the angle that we figured out we're using is 7 pi over 6. And that equals, we're going to put a minus in the front. And it would be 1 plus the cosine of 7 pi over 6. And that's all divided by 2. So go to your unit circle. Figure out what that is. What is the cosine of 7 pi over 6? Because we agreed that that's the angle we have to divide by 2 to get 7 pi over 12. So I'm going to just follow my steps. And this time it should go a little bit faster. Make sure you drag that negative along though. So we got 1 plus And then I'm going to put a negative root 3 over 2. That's all over 2. When you add a negative, can we just make that a subtraction in the numerator? Make it simpler? Okay. So then we have, I'm going to break it apart. In the numerator and in my denominator is just 2 over 1. So my numerator would be 1 minus root 3 over 2. So we need to write this as a common denominator. So that would be 2 over 2 minus root 3 over 2. So then, oops, I messed up. What did I do? I dropped my negative. Can't drop that negative. Let me put that in the front. That's important.
Because you said if it's positive, you don't have to.
Yeah, if a number is positive, we don't go around putting a plus sign in front of everything that's positive. But if it's negative, we have to put that negative. So I got to keep dragging that negative along. Okay, so now we have our common denominator. So the numerator will become 1 fraction, 2 minus root 3 over 2. And then I'm going to do my keep, change, flip. So I'm going to change this, and this becomes a 1 over 2. So from here to here, I did 2 things. The first thing I did was merge this together to make 1 fraction. And then I also did keep, change, flip. Keep, change, flip. So let's multiply across. And when I multiply across, my numerator will be 2 minus root 3. And that's all over 4. And then when we break it apart, I'm going to have my negative, and I have my fraction bar. And I'm going to put a square root top and bottom. So I have 2 minus root 3 all over 4. And fortunate for us, we have a perfect square in our denominator. So we don't have to keep going. We can actually stop right there. So my final answer would be a negative. And then it would be a square root, 2 minus root 3 all over 2. And this is my final answer. Half angles, in my opinion, they're the hardest as far as what we're working on the back. Sum and difference is easy. Double angles, pretty simple. But the half angles, because we have a square root and a fraction, they're a little tricky. So now you can do all of homework 12, and I would recommend you take it out and use it now. Use this time wisely to work on homework 12 and ask questions. We are going to practice more tomorrow, though.